Welcome to MySafetyTrainingOnline.com presents Confined Spaces for Sewage Facilities. What will we talk about in our program? We will establish in writing and implement a system for issuance, use, and cancellation of entry permits. We review established entry operations and revise annually established permit space programs. When an attendant is used to monitor multiple sites, we'll implement emergency procedures for one or more spaces being monitored, and we'll define within the confined space program all the terms being used in the program. Section 1, Introduction to Confined Spaces for Sewage Treatment. Here we can see a typical sewage treatment facility where the screening of foreign objects occurs, followed by pumping facilities, aerating facilities, and removing sludge, scum, and bacteria. An entrant is defined as an employee who will physically enter the confined space to perform the work. An attendant is defined as a person who will remain outside the confined space and monitor the entrant or entrance. An attendant's job is to warn the entrant of any unusual conditions, summon rescue personnel if necessary. An entry supervisor is defined as someone responsible for coordinating the entry into the confined space. This must be a team leader or foreman. A responsible person is defined as the person who will directly responsible for the work inside the confined space. It can be a team leader, a foreman, or a journeyman. A permit-required space meets the following criteria. It contains or has the potential to contain a hazardous atmosphere. It contains material that has potential for engulfing the entrant, or has an internal configuration such as the entrant can become entrapped or asphyxiated. The history of confined spaces in sewage treatment facilities has documented cases of worker deaths, very serious health and safety hazards. This training program will identify them and offer methods of controlling these hazards. Deaths have occurred in confined spaces if you work in one of these following areas: septic tanks, sewage digesters, pumping and lift stations, sewage distribution or holding tanks, silos, ducts, vats, utility vaults, pits, pipelines, boilers, or reaction vessels. In case number 1, we have a 54-year-old male who died inside a floating cover of a sewage digester while attempting to start a propane heater that was being used to warm the outside cover of the sewage digester prior to painting it. Workers had wired the safety valve open so the flow of propane would be constant. An attempt to start the heater led to the death of the worker and the rescuer. In case number 2, a 20-year-old worker died of carbon monoxide when attempting to restart a gasoline-powered pump used to remove waste from a 66-inch diameter sewer line that was under construction. The pump was approximately 3,000 feet from where the worker entered the line. A co-worker escaped, but a 28-year-old inspector entered from another point and also died. 38 others were also treated in the incident. In case number 3, we have a 27-year-old sewer worker who entered an underground pumping station measuring 8 feet by 8 feet by 7 feet via a fixed ladder inside a 3-foot diameter shaft. The transfer line was still under pressure and the worker removed the bolts from an inspection plate that covered the check valve. The force of the wastewater blew the cover off and flooded the chamber, trapping the workers. A co-worker, rescuer, and policeman all died in an effort to save the workers. Confined spaces are a major hazard to workers who are required to work within these areas. Confined spaces include, but are not limited to, storage tanks, process vessels, pits, vats, vaults, sewage digesters, sewage silo tunnels, manhole utility vaults, pumping stations, enclosed grit chambers, or similar types of enclosures with limited access and without proper ventilation. Entry into confined spaces may be for the purpose of inspection, testing of equipment, maintenance, repair and cleaning, or an emergency. To prevent confined space deaths and injuries, the Occupational Safety and Health Administration issued its final rules for confined spaces in 1910.146 in January 1993. Section 2. OSHA regulations covering 1910.146, as well as confined spaces in sewage treatment facilities. Identifying a confined space. The characteristics of confined spaces are a space that is large enough and so configured that a worker can enter and perform assigned duties. A space that by design has limited openings for entry and exit. Openings are usually small and difficult to move through. Small openings may be difficult to get needed equipment in and out of the spaces, especially personal protective equipment needed for entry and work, or life-saving equipment needed for rescue. OSHA defines a confined space as a space not designed for continuous employee occupancy. Most confined spaces are not designed for employees to enter and work on a routine basis. They are usually designed to store products, enclose materials or processes, and to transport products or substances. However, workers must enter these spaces occasionally for inspection, maintenance, or cleanup. Section 3. Hazards of confined spaces in sewage treatment facilities. Hazardous atmospheres. The most common hazard in a confined space is hazardous atmospheres. These hazards include oxygen deficient, oxygen enriched, flammable, or toxic atmospheres. Oxygen. An oxygen deficient atmosphere means that there's not enough oxygen in the space. Normal air is composed of 20.8% oxygen. An oxygen-deficient atmosphere has less than 19.5% oxygen, and levels below 10% can cause unconsciousness, and levels below 8% can quickly cause death. Low oxygen levels in confined spaces are caused by chemical reactions, the breakdown of sewage and other organic matter, such as domestic waste and plant life. Low oxygen levels in confined spaces can be caused by work being done in the place, such as welding, cutting, or brazing. In order to have safe conditions in a confined space, the oxygen level must be between 19.5 and 23.5%. Any level below 19.5% is dangerous and will affect the worker's health and safety. If a confined space has less than 19.5% oxygen, it must be ventilated and should not be entered without self-contained breathing apparatus, or SCBA, approved by the National Institute of Occupational Safety and Health, NIOSH. An oxygen-enriched atmosphere, too much oxygen, above 23.5, will cause flammable materials such as clothing and hair to burn violently when ignited. Never use pure oxygen to ventilate a confined space. Ventilate with normal air that consists of 21% oxygen, 78% nitrogen, and 1% noble gases. Flammable atmospheres are caused by the buildup of methane or flammable dust, gases, or vapors can cause deadly fires and explosion. An explosion can occur only when a certain mixture of fuel and air is present. If there's too little fuel, then the mixture will be too lean to burn. Flammable atmospheres for a source of ignition, such as electrical tools, is introduced into a confined space where the mixed fuel mixture is above an LEL, lower explosive level, or below the UFL. Then a fire or an explosion may occur. Use only explosion-proof equipment and spark-proof tools. Other atmospheric hazards, such as naturally occurring ones, are the three most common naturally occurring ones of toxic gases in the form of carbon monoxide, hydrogen sulfide, and methane. They originate inside the wastewater treatment facilities by a natural breakdown of sewage, sludge, and rotted materials, or as a result of chemicals added to the plant to treat the sewage. Hydrogen sulfide is a flammable, colorless gas that is created by the decay of organic matter that is found in sewers and sewage treatment facilities. Hydrogen sulfide has a strong, rotten egg odor. Workers who come in contact with hydrogen sulfide quickly lose their ability to smell the gas, even though the gas is still present. Carbon monoxide is a very toxic, colorless, odorless, combustible gas that is the product of incomplete combustion. It is created by arc welding and combustion engines. In high concentrations, carbon monoxide can cause death by asphyxiation. Methane is a colorless, odorless, flammable gas that displaces breathable air in a confined space and can cause suffocation. The most common source is a natural decay process of materials such as raw sewage, leaves, and weeds. Section 4. Outside the sewage treatment facility hazards. Toxic gases and vapors can also originate outside the wastewater treatment process. Chemical spills or illegal dumping can cause large amounts of toxic materials to enter the sewer and treatment plants. Substances spilled or dumped into the sewers can cause short-term or long-term health effects, such as explosions. The dangers of toxic discharges are often complicated and unpredictable. For example, two harmless substances dumped into a sewage treatment facility miles apart can combine downline to produce a chemical reaction that results in the release of poisonous gases by the time it reaches the workers. The types and quantities of toxic chemicals a worker may be exposed to depend on the industries in the surrounding area. Major categories of toxic chemicals include organic compounds. Thousands of commercially available organic substances may find their way to a plant. Contamination may be especially bad if the sewage plant receives waste from a chemical or pesticide plant. Many of these chemicals volatilize or evaporate as they pass through the sewers and the treatment plants, especially grit chambers, wet wells, settling tanks, aeration basins, and activated sludge processes. Evaporation of these substances also contributes to a general air pollution. In sewers and enclosed areas, chemical fumes accumulate which may be explosive, flammable, and dangerous to breathe. The most common organic compounds dumped or spilled into the sewers are gasoline from sewer service stations that is irritating to the skin, eye, and mucous membranes and contains several organic compounds that can be dangerous. Most notable are hexane, which can cause nerve damage after chronic exposure, as well as benzene, which affects the formation of blood cells and the bone marrow and causes leukemia, a cancer of white blood cells. Pesticides such as malathion, parathion, 2,4-D are just a few of the more common chemicals that can cause nerve damage, cancer, birth defects, or miscarriages. Cancer-causing agents such as PCBs are found in electrical transformers and storage dumps and can be in the sewage system, as do solvents and degreasers such as trichloroethylene or carbon tetrachloride. Acids and alkalides such as sulfuric, nitric, and hydrochloric, as well as alkalides of potassium hydroxide, sodium hydroxide, and ammonia are also frequently discharged into the sewage system. Acid and alkali fumes and vapors can irritate a worker's nose, throat, and lungs. It is very important for workers to know the particular substance that can be found in a particular confined space that will be entered. Remember that solvents, pipe grouts, paints, pesticides, and other materials can cause serious health hazards. Entrapment. Entrapment is when spaces with sloping, converging walls that empty into smaller cross sections can trap a worker in a cross section, causing suffocation or severe injury. Falling objects. Workers in confined spaces should be aware of the possibility of falling objects, especially in places that have topside openings where work being done above the worker. Unguarded machinery. Machinery that is unguarded may strike a worker and cause feet or hands to be caught or cause other kinds of injuries that can cause hazards to employees who work in confined spaces. Electrical hazards. To control electrical hazards in the facility, routinely inspect all electrical equipment and tools and use ground fault circuit interrupters for low voltage transformers. Access to ladders. It is essential that authorized entrants be able to safely enter and quickly evacuate the permit space. Fixed or portable ladders are used for access. Ladders may be the only means of entry and exit. Ladders must be equipped with a non-slip base and should be tied at least at the top. Extend the ladder at least 3 feet above the top of the surface. The ladder should be placed so that the horizontal distance from the base of the vertical plane to the vertical plane is approximately 1 1/4 the ladder's length. For example, place a 12-foot ladder so that the base is 3 feet from the wall. The ladder must be maintained in good condition and should be inspected prior to each use. A fixed permanent ladder in a confined space should be checked visually for slippery or corroded rungs prior to using it. If a worker is at risk from falling from a ladder, have the employee wear a full body harness attached to a fall arresting and retrieval device. Adequate lighting must be provided to allow authorized entrants to safely enter and exit the confined space and to perform their work tasks. If flammable or explosive atmospheres are possible, lighting must be intrinsically safe or explosion-proof. To prevent electrocutions when water may be present, lighting must be connected to a ground fault circuit interrupter. Animals. Sewers, wastewater treatment plants, and other confined spaces can contain snakes or rats, etc. Protective equipment, exterminators, and other physical changes to the workplace may be needed. When trenching and excavation occurs, sewers and maintenance work and other public works personnel may perform excavation and trenching operations in order to service broken lines or replace valves. Workers are killed when excavated soil falls back into an excavation, when the walls of a trench or excavation collapse, or when water collecting in a trench causes the soil to become unstable. A protective system such as shoring must be installed in trenches or excavations before workers can enter them. Trenches and excavations may also contain hazardous atmospheres. For example, excavations in landfills or trenches dug around sewer lines may have the potential for containing methane, hydrogen sulfide, or some other flammable or toxic gas to accumulate in the trench or excavation. There may also be a potential for oxygen-deficient atmospheres in the trench or excavation, as well as the possibility of engulfment, which is a common problem in unsloped or unshored excavations, or other physical hazards in the trench or excavation. See My Safety Training Online's program on excavation safety for more information. Section 5. Management and Confined Spaces for Sewage Treatment. Management needs to identify and evaluate all potential confined space hazards, documenting all the analysis work that they do. Test the conditions in the permit space before anyone enters the space, documenting what you have done. Perform all the following in the following sequence: an appropriate testing for oxygen, combustible or flammable gases, or toxic gases or vapors. The administration needs to implement unnecessary measures to prevent unauthorized entry. They need to establish and implement means, procedures, and practices such as specifying acceptable entry conditions, isolating the permit space, and providing barriers. They need to verify acceptable entry conditions exist, purging or making inert, flushing or ventilating the permit space to control or eliminate hazards. Identify employee job duties, provide, maintain, and require the use of personal protective equipment and other equipment necessary for safe entry, such as testing, monitoring, ventilation, etc. Ensure at least one attendant is stationed outside the permit entry area for the duration of the entry. Sewage treatment facilities include sewage and lift pumping stations, sewage distribution or holding tanks, silos, vats, ducts, utility vaults, pipelines, as well as boilers or reaction vessels. Several of these locations are below ground and have a stair entry for access to routine maintenance, inspection, testing, sampling, and repairs. The level of fall protection necessary depends on the facility, its required activities, and the job tasks being performed. Full body harnesses, ladder safety systems, tripods, hoists are some of the more important fall protection products. Although some of the above locations might not be deemed confined space according to regulations, many facilities lean toward the side of safety and do treat them as confined spaces. OSHA defines a confined space as an area that is large enough and so configured that an employee's body can enter and perform assigned work, and has limited or restricted means for entry or exit, and is not designed for continuous employee occupancy. Section 6. Entering a non-permit space. All confined spaces need to be considered immediately dangerous to life unless proven otherwise. When unexpected hazards arise, the escape or rescue of a worker may be difficult due to a limited number of entrances or exits. Therefore, entry into a confined space requires planning in advance to deal with the potential hazards. Okay, here we can see where the danger confined space is mandatory for management that has found such spaces as meeting the confined space restrictions. Based on the hazards present, these spaces will be categorized as either permit required or non-permit required confined spaces. A permit required confined space has the potential to contain a hazardous atmosphere or material that can cause engulfment of a worker. Entering a permit required space. This has an internal shape that might cause the worker to be trapped or asphyxiated by inwardly converging walls or by a floor that slopes downward or tapers to a smaller cross-section, or contain any other recognized serious health hazard. A written confined space entry program must be developed and implemented if an employer has its workers enter a permit-required confined space. The program must be available for inspection by the workers and their authorized union representatives. In this program, the employer must describe how he or she will comply with the requirements of the standard. The written program must include the following: the procedures that the employer will use to implement the measures necessary to prevent the unauthorized entry, identification and evaluation of hazards of permit spaces before employees enter them. A permit-required confined space program will also include a list of equipment needed to perform safe entry operations, procedures for atmospherically testing of a space, and a provision for at least one attendant outside the space. A permit-required confined space program includes a provision for responding to emergencies if the attendant is monitoring more than one space, a designation of all persons with active roles such as entrance, attendants, persons who test and monitor, as well as the provision of required training. It should have a system for the preparation, issuance, and use and cancellation of entry permits. A permit-required confined space has a system developed and implemented for the closing off of permit spaces and the cancellation of all entry permits. Procedures should to coordinate the operation where more than one employer, such as a contractor, is involved. Procedures for evaluation and correction of entry operations when the employer has reason to believe the program is not sufficient protective, and a mechanism by which confined space permit entry program is reviewed. Section 7. Elements of an entry permit. An entry permit must be filled out before the worker enters the confined space and posted at or near the confined space. It should contain the following types of specific information concerning the identification of the space, the purpose of the entry, the date and duration of the permit, and the list of the authorized entrants. Entry permit elements include the names of current attendants and the entry supervisor, the hazards of the permit space to be entered, the measures used to isolate the permit space and eliminate or control the hazards, and the acceptable entry conditions, the results of atmospheric monitoring, rescue and emergency services that can be summoned, and the means for summoning those services. Entry permit elements include the communication methods used by the entrants and attendants to maintain contact and any other safety information necessary for specific spaces, and or additional permits such as hot work or welding permits. The entry permit is a document that certifies the employer complies with the requirements of the standards for entry in a permit-required confined space. Entry permit elements include the entry supervisor must close off the space and cancel permits when an assignment has been completed or when prohibited conditions exist. All new conditions must be noted on the canceled permit and used in the revising the permit space program. Section 8. Rescue procedures for confined spaces. An emergency in a confined space can kill an entrant in a matter of minutes. In order to facilitate rescue without having the rescuer enter into space, OSHA requires the use of non-entry rescue retrieval systems or methods, such as tripods or winches, to lift unconscious, injured entrants out of a space that is more than 5 feet deep. In vertical entries, the safety harness should be attached to a retrieval device that will allow a quick removal of an employee. In the event of an emergency, the attendant located outside should be able to initiate a rescue without entering the space. Where entry must be for rescue, OSHA allows rescue to be performed either with the facility's in-house rescuers or by contracting to an outside rescue service. In-house rescue. Rescuers must have extensive training that is documented. No worker is authorized to enter a space to rescue an entrant without extensive training in personal protective and rescue equipment. This includes actual practice in making simulated rescues and CPR. Even a trained attendant may not enter a space to make a rescue, even if he or she is trained, until another attendant has arrived. Outside rescue. OSHA's confined space regulation has the ability of employers to use outside rescuers such as fire departments. If this is done, the rescue service must be informed of the hazards they may confront, and the rescue service must have access to all permit spaces so that the rescue service can develop an appropriate rescue plans and practice rescue before a rescue must be made. Note, never assume the fire department or rescue squad is trained or equipped to make a confined space rescue unless the requirements listed above have been met. It's not enough just to assume you can call 911 in an emergency. Training. Proper training, careful preparation, and good judgment are all essential in safe confined space entry. If the employer is required to provide initial and refresher training to equip employees with the understanding, skills, and knowledge necessary to perform the confined space safely, training should be provided to each affected worker before performing the assigned duties in confined spaces. The entrant must be certified by the employer. Entrants, attendants, supervisors, and rescuers require different levels of training according to their specific duties and responsibilities. While OSHA does not require any specific number of hours for training, the AFC-SCME requires the minimum amount of training for an entrant or attendant should be 24 hours. Where there has been previous training on a respirator use or air monitoring system, 16 hours may be sufficient. Training for rescuers should be at least 40 hours. Confined Spaces Safety Summary, Part 9. Confined Spaces Standard, or CFR 1910.46, Fall Protection and Walking Working Surfaces, 1926-500, Subpart M, Guarding Floors, Walls, Openings, and Holes, is covered under 1910.26, hazard communication 1910-1200, ladder safety 1910.27, and the laboratory standard under .1450, as well as lockout, tagout, and personal protective equipment, are all standards applying to sources of information for this particular training program. An entry permit must be filled out before a worker enters a confined space and posted at or near the confined space. It should contain at least the following types of specific information concerning the confined space potential hazards of hazardous atmosphere, as well as material that can cause engulfment of a worker. The most common hazard in a confined space is a hazardous atmosphere. These hazards include oxygen-deficient atmospheres, oxygen-enriched, flammable, or toxic atmospheres. Remember, an oxygen-deficient atmosphere means there's not enough oxygen in the space. Normal air is made up of 20.8% oxygen, whereas an oxygen-deficient atmosphere has less than 19.5%. Toxic gases and vapors can also originate from the outside, the waste treatment facility. Chemical spills or illegal dumping can cause large amounts of toxic materials to enter sewers and treatment plants. And confined spaces are major hazards to workers who are required to work within these areas. Confined space include, but are not limited to, storage tanks, process vessels, pits, vats, vaults, sewage digesters, sewer silos, tunnels, manholes, utility vaults, pumping stations, and enclosed grit. To prevent confined space deaths and injuries, OSHA issued its final rules on confined spaces in .146 in January 1993. Hey, thanks for participating from the gentle folks of MySafetyTrainingOnline.com. We loved having you.